are going to discuss about the previous gate paper question from the subject of communication system. Okay, here this topic is especially related to the digital communications. Okay, here this question is given in the year of gate 2003. Now the question is, the input to a linear delta modulator having a step size delta equal to 0.628 is a sine wave with frequency FM and peak amplitude EM. If the sampling frequency Fs equal to 40 kHz, the combination of the sine wave frequency and peak amplitude where slope overload distortion will take place. Okay, to occur the slope overload distortion, what combination of sine wave frequency and sine wave amplitude is required? Okay, here different peak amplitudes are given and different frequencies of that given waveform is also given. For which combination generally a slope overload distortion is occurs for the above given data. Okay, now we'll see the solution for this one. Okay, here the given data is nothing but here the delta value is given, that is nothing but 0.628, and similarly the sampling frequency Fs is also given, that is nothing but the 40 kilohertz, and here FM is considered as the frequency of the sinusoidal signal and EM is the peak amplitude of the sinusoidal signal. Now for slope overload distortion, for slope overload distortion, for slope overload distortion in delta modulator we have a condition. Okay, based upon this condition the slope overload distortions occur in the delta modulator. Now the condition for the slope overload modulation is slope overload distortion is delta into Fs less than 2 pi FM into AM, or here the peak amplitude is given as EM, where delta is the step size, Fs is the sampling frequency, FM is the frequency of the signal, and EM is the peak amplitude of the sinusoidal signal. Okay, this is the condition for the slope overload distortion. Whenever delta Fs is less than 2 pi FM into EM, the slope overload distortion occurs. Now we have to, for this problem we have to find out the product of the delta into Fs. Just compare the given this FM and EM combinations where this condition satisfied, for that combination the slope overload distortion occurs. Now first we will find out this delta into Fs. Delta value is given as 0.628 and the Fs value is given as the 40 kilohertz. Now this value equal to 25.12 kilohertz. This is nothing but in terms of 25.120. This is 25120 is the delta Fs value. Okay, this 25120 less than 2 pi FM and EM. Okay, here just compare this condition where this 2.1250 is less than for the FM EM values, that is the correct combination to produce slope overload distortion. Here in the problem 4 options are given. For these 4 options we will find out the FM into 2 pi FM into EM. Okay, FM into EM is nothing but similarly the FM into EM for the option A equal to 15079.6, for the option B 37699.11, and for the option C the value is 18849.5, for the option D also 18849.5. Okay, for the given options these are the product of the FM EM values. Now compare with this 2 pi 120. Okay, here this one 2 pi 120 must be less than for these values. Okay, here this 2 pi 120, first compare the A option. here 1507 and here 2 pi 120. So here this condition is not satisfied at this one, and here 2 pi 120 is compare this one less than this one, this is okay. And here 180, here the 2 pi 120 is greater than this one, so this is not correct answer. Here the same, this is not correct answer. So the option B, where 2 pi 120 is less than compared to 37699.1. now the correct option is, that is B. Okay, to produce slope overload distortion we have to satisfy this condition, that is nothing but delta fs into 2 pi fm and em. We find out here delta fs value and here fm em for the given all the options. Just we compare, we at the option B only this delta fs value is less than comparative to 2 pi fm into em. That's why if em equal to 1.5 volts and if fm equal to 4 kilohertz, then only the slope overload distortion occurs corresponding to the step size 0.628 and the sampling frequency 40 kilohertz. Okay, the correct option is 1.5 volts and